Greetings, everyone. I am Güray Hatipoğlu. I'm the owner of the Fire Research and Training Limited company. The company is on scientific research, training, giving some outreach activities, and especially publishing Science Ascent. Science Ascent itself, again, focused on astrophysics, the cutting-edge research in this field, relevant tools, and also professionals and academics from the same field again. Wolfgang Kerzendorf, our current guest this time, as you can see, is one of the most important and interesting people from that field. Thank you very much again for accepting this interview.
Thank you so much for having me.
So he's currently affiliated in Michigan State University as an assistant professor in astrophysics and computational mathematics, science and engineering. But without further ado, I'm giving the floor to Wolfgang Kerzendorf. The first question is, of course, please briefly introduce yourself to us, to the audience.
Yeah, I mean, thank you very much for having me. Yeah, as you already said, I'm an assistant professor in the physics and astronomy department at Michigan State University, but I'm also cross-appointed to a new department. We just celebrated our 10th year anniversary called Computational Mathematics, Science and Engineering. So it's computational mathematics, computational science, and computational engineering, which is in effect like an interdisciplinary department that thinks about how do we bring computational tools, specifically also machine learning and algorithms to science, to engineering, and to mathematics, and how do we work together in interdisciplinary fashion. I did my PhD at Mount Stromlo Observatory, and I was trained as an observer and did supernova hunting for supernova companions there. But in the meantime, I've switched fields mildly in astrophysics and do a lot of reconstruction of observations using a simulation tool called TARDIS. It's a so-called radiative transfer code. Essentially, radiative transfer codes exist in popular culture as well. Blender is one of them. The CGI is doing a lot of radiative. If you see CGI movies, then there's a lot of radiative transfer going on. We are doing this not as flashy and not as beautiful looking, but physically correct. And so we're figuring out how does a exploding star look like given a certain input, and then using this to reconstruct things. And so I'm the founder, or one of the founders. The other founder is Stuart Sim, and principal investigator of that project. The interesting thing about this, it's open source, so it works quite differently. We have many people helping out, and but it's a large community by now. And then, as I already said, we use machine learning and statistical tools to then use that code to then infer the structure of exploding stars from observations. I think that's mostly maybe not that unusual. Maybe one more unusual thing about me, maybe 10 years ago, I started a project to think about literature, scientific literature, as a big data problem. And back then, I had colleagues that sort of said, well, you young people, you need to your literature much better than you do. And I always agreed. And I said, they're not wrong. But then I sort of also looked up what was the literature when they did a PhD at the beginning of the 90s. It was, a few hundred to 1,000 papers per year. And now we're at 25,000 papers per year in astronomy alone. And I think the number of papers in astronomy doubles every 11 years. So I think it's really an interesting time. I think as humans, we have never had so many people producing science and producing papers as before. And I think we have to think about different ways of running the system, because it was not designed for this kind of for this many people doing science, which is great. I think it's always a great thing that so many people are doing science. And this was a long introduction, and I'm sorry, I should have probably cut it short, but I'll hand over to you again.
No, it wasn't definitely too long or anything for our purpose, so no worries about it. It's very interesting actually, since when we try to make literature review, we're trying to search through what has been published in the last week, let's say. It is very hard to just finish them because we have many other things to do. So human brain is not capable of completely reading what has happened anymore.
That is very true. That's exactly what we sort of like found, and this is something that my other collaboration, the Deep Thought Initiative, is thinking about. Like, to know mm, how can we make a better environment for science to like build on top of other scientists, and we're specifically also interested, is there algorithms that would help with this, and then from our open source nature is, can we make computational tools that help with that.
It is very interesting because from my experience when I first started to publish Science Ascent, I was thinking about completely making a literature review almost continuously, like each week. What happened in the astrophysics in the last week? I mean, I
Yeah,
try to narrow down topics as much as I can, and when you narrow down enough, you actually miss out a lot of things too. And it was still so tiring about it. So just at some point I was just trying to filter through astrophysics archive preprint part completely on Earth and planetary science, and then I see myself starting to filter out many papers on that field too, and it
yeah,
starts to lose its competitive edge and the, let's say, the coverage, and then Horizon Death Track completely burn out. I just gave up
yeah.
on that completely.
Yeah, no, I mean, I think that's something that we're all struggling with, and like there's these large language models are somewhat helpful, but they have many drawbacks as well, and like not really intelligent and useful, but come with other drawbacks. But yes, it's a very interesting time to be a scientist. It's a very, yeah, in many good ways, but also some bad ways.
Yeah, sometimes exciting, sometimes anxious.
Yeah, yes.
So, okay, let me move to the second question now. How did your study in Heidelberg University influence your later career choices then?
Like before I chose physics, so I did my undergrad in physics in Heidelberg, and I think you said you will have questions about this later on as well. But I was always interested in computing. I found computing very fascinating. I think I started my first computer was a 286, which probably most people don't know anymore what that is. The chip in the early 90s that I inherited from my dad. Really enjoyed playing around with this, and learned Turbo Pascal, and I found computing very interesting. And I think my dad told me, like, computing is great, but if you can apply it to something, it's even more fun. And I really enjoyed physics, and so I think that's how things got started. And I remember also that in high school, I really also enjoyed astronomy. And so I think like I always was interested in physics and astronomy, and I chose Heidelberg as a physics place because they also had a strong astronomy department, which is unusual in Germany. Astronomy is not such a big science as compared to other countries. Um, and yeah, I mean, I know. Then I remember when I was an undergrad, we had these labs, and one of the labs was the astronomy lab. And we went up to the Königstuhl, which is a mountain near Heidelberg, and they have a telescope there, and we observed a globular cluster and did isochrone fitting, and I remembering installing IRAF, which was a sort of a analysis tool that was written in the early 80s, and did the analysis of the brightness of stars in different colors, and then you can use this to measure like the age of stars, and I found it really fun, and that sort of got me further, and then got me connection to Mount Stromlo Observatory, where I then did my PhD.
Yeah, thank you very much. And the next question is on about your PhD in the Mount Stromlo Observatory in Australia. So I'm directly asking that. So what are your best, most exciting, and worst memory in this observatory? You can
Many
start with
bests, I
any of
want to
them.
say. Sorry.
You can start with any of them. Order is not that important.
Yeah. Um, I really, there's many good memories I had. So I came there as an undergrad. In here in the US, it is called an RU, a research experience for undergrads, which is in the summer. And at Stromlo was called a summer scholar for, so that was there for 3 months. And then I met several students there, and one of them was now a professor at MIT, a woman named Anna Freibel, and she told me that you could start your PhD there potentially without finishing your undergrad, which is essentially what I did. And the
Mm.
support I received from Mons Drumroll Observatory, specifically for my PhD, at my later PhD advisor Brian Schmidt, was really astounding. Like, they all trained me in rate of transfer, in interstellar medium. So I learned a lot because I was trained as a physicist, and Mike Bessel taught me about photometry, and like I learned a lot through this. And I think the community that existed was something special. You were up on this mountain, like there was no lunch place, so you had to bring your own lunch. Everyone had lunch together, and I really, really and enjoyed myself. And I mean, I have to say, like, there's in my life, this is definitely a time where I don't have many bad memories, or I don't really. I mean, I would have to sit down and think about bad memories. It was really an amazing place. I mean, the end for any PhD is always stressful, and I remember um, for 4 months I came in almost every day and finished this to try to finish this. But ultimately, this is what it takes to do a PhD.
Yeah.
It's like you're training for the Olympics, right? I mean, you just have to sit down and like, and it has to motivate you. I've now, I mean, over my now longer career, I've seen so many people that like don't enjoy their field of study, but they really want that PhD. And I think it always ends in disaster. Like a PhD doesn't tell you how smart you are. A PhD just like gives you PhD just gives you like an opportunity to do something that you're really passionate about it, and it's hell. Like I worked every weekend, not because I had to or my boss forced me to, but because I really wanted to get these interesting results that I was keen about out. And I think everyone who sort of like stopped doing their PhD most of the time was because that was not the thing that they were passionate about. And I remember someone specifically who like got really into photography, and I remember she stopped doing the PhD because it's like her passion then switched to photography, and she became this famous photographer. I forgot her name, but yeah, no. So I think a PhD, what it taught me is like, you have to be passionate about things, and it taught me a lot about like, going after things that I would never thought I would be able to do, because I had that passion and the people that were very supportive. I think I think that sums it up. I'm sorry I don't have any bad memories, but I think like,
No,
the
no.
last months were not super fun, but this is it's part of the journey.
Yeah, that's sufficient for me. No problem again. Yeah, I can also watch for passion requirement and PhD completion stuff because I
Yeah,
have my passion for the astronomy, astrophysics part at that time, and I
yeah.
lost my passion in my Earth system, Earth system science PhD thing on my water
Which
class.
is
So I
normal.
was unable
Yes,
to finish it
yes,
as a poor
yes.
bad example of the passion absence and the PhD part. Then
I mean,
again, I
there's an
was.
economist. I think. Okay, go ahead.
Oh,
Sorry.
sorry.
There's an economist called, I think, Stephen Levitt, who I think said like, quitting is underrated, and I think that is very true. I think like, if I mean, no, like everyone has days that are not great, but if you sort of like do this for a month or more, I mean, it's not worth it. Like the letters in front or after the name or whatever, it's just, I mean, there's too much to life, than to like, force yourself to do something that is not really what you want to do, what you want to spend your time doing. So I applaud when people say like, no, that's it, and they do something else great and they become leaders in other fields. I think that's always great.
Yeah, actually, I definitely realized that if I don't like a thing to do, there's just almost
Yeah,
it is just almost impossible to do something really
yeah,
worth reading afterwards.
yeah,
Maybe I
yeah,
would be
yeah,
able to read because I have like spent 4 years on it, but no one else would do
yeah,
because it wouldn't be really enough in the quality.
yeah.
So I also think I have done something good about that as well. So thank you very much. So actually, the next question is again on PhD topic, but from a different field. So we always need to choose a thesis topic when we enter a PhD study, maybe right from the start or after some points. You also choose your thesis on type 1a supernovae. But at the same time, through the PhD process of several years, there are some changes in the starting point through the end of one. So I wonder how much of a things happened as you imagined, as together with your advisor, and what actually changed as a even the percentage works for me.
Um, I mean, I, I, I mean, interesting enough, like I found astronomy fun, and the first sort of science connection I had with astronomy was measuring a globular cluster, doing a color magnitude diagram of a globular cluster, which I still remember to that day. And then when I sort of want to do a semester abroad, I reached out. Mike Bessel, who's an astronomer at Stromlo, was visiting, and the unfortunately late Rainer Werzer, who died, I think, like no more than 10 years ago, was one of my mentors, and like, I owe him a lot of, like, I'm very grateful for him, because I wouldn't be here without his help. And so he knew him, and I was then gotten in contact with Mike Bessel, who then got me in contact with Brian Schmidt, who wrote me and said, like, yeah, if you want to come, we have the summer scholarship, and like, are you interested in gamma ray bursts? And I said, sure, because I didn't have like I found astronomy interesting, but if he said, are you interested in exoplanets, I would have said sure as well, or interested in magnetars or whatever. So I did not really choose my topic, let's put it this way. And then one of the first projects that I started as an undergrad was to investigate companion stars for type 1a supernovae. So maybe for the listeners, there's various different classes of supernova explosions. Many of them probably that are known as, like, it's a big star, like 10 times the mass of the sun, which collapses under its own weight, or roughly 10 times the mass of the sun, which is, I think, what's often portrayed in movies. There's a separate kind of explosion that we've used since the 90s to measure distances in the universe, that have given us Nobel Prizes, and I'm happy to, like, elaborate on this later, called Type 1a supernova, which are essentially remnants or corpses of stars that are Earth-sized, made of carbon oxygen, and were thought to be fed by a companion star. And one of my first projects was to look at one suggested companion that may have been the star that, like, essentially lit this white dwarf. And we found that it unfortunately just didn't fit the bill. But that was sort of my entry into type 1a supernova science. So I looked at stars. I didn't look at exploding stars, but looked at stars. And then the idea was, as you mentioned, like, what does change? I think the idea was that we would use a new telescope that Brian was building called SkyMapper for my thesis. And I think it was supposed to be starting survey operations in 2007 or 2008. I started my PhD in 2007. But like many of these things, they're incredibly complex. And so, like, I think JWST was 15 years late. And so SkyMapper was not 15 years late, to Brian's credit, but was, I think, 5 years late. So I think it started survey operations in 2011 when I finished my PhD. So originally I was going to do type 1a supernova physics with SkyMapper and using SkyMapper data, but then my main field of study became hunting for these companion stars, which we now know are likely very rare and don't quite exist. And my personal relationship, I think, has intensified with Brian. I think he's been a mentor of mine and has been a friend of mine, and I don't know, continue to connect with him on various topics.
Yeah, very interesting. So now I'm moving a bit more on the PhD, after the PhD career part of yours now. We will, of course, talk separately about the computational metascience topic you introduced us a bit at the beginning, and also astrophysical transience parts. Excluding those parts now, could you pinpoint some major points on your career after PhD, or put it in this way? Let me put it in this way. Like, I mean, since there are a lot of PhD finishing them, and like feeling like they are completely on the void somehow, now how to move forward, what to do, etc. So it's a bit important for the audience and also to me to hear about how you move through that part and choose some other things, some major career points of yours.
Yes. I think before I answer that question, I think it is very important. I got advice very early on in my career, which is very good advice, which I also give my students, which is like like every career path and every path in life, maybe on a more philosophical level, is unique. And so comparing, it is always important to not compare yourself to other people, at least in quotation marks, too much. And we
Yes.
all do this. And I mean, I now do this much less than I used to, like look up how many citations my immediate, like, you know, friends and colleagues and competitors have, and to sort of to look to have enough citations to get a job or something like this. I could have never predicted my path, and I think it was a lot of random encounters. So, like, I think that is one I did not. This was not planned at all. And in, I don't know, 2010, I was very much under the impression there's a life can be planned, which I now know it cannot be. You are along for the ride, and you can steer it a little bit here and there, but I think there's not that much planning. So immediately after my PhD, I applied to various postdoc positions, and was interviewed for a postdoc position at University of Toronto by a professor named Martin van Kerkwijk, who, like, I'd never really heard about before, and was not known in the 1A field. And he sort of said, like, I found your research interesting. I just have this money for going from, he's a neutron star theorist, well, neutron star observer slash theorist. And but I just got this grant for type 1A supernova science, and you seem to be doing interesting stuff. And like, to know, is this something? And I mean, no, obviously asked friends, like, do you know anything about this? And one of my friends said, like, yeah, I have a friend of mine, and she worked with him as a PhD student, and he's great. He's a great person to work with. I think this is something that is underrated. I think, like not everyone can work with everyone else, and like, yeah, some people, like, you click more, or you have a similar work style to some people, whereas you don't have a great work style with other people. And so inquiring about this, like, it's great if you can work with a Nobel Prize winner, but if you don't get on with this person, like, it's that's not fun. And so, like, it's always important to know it's not only about, like, the science. It's also a lot about, like, spending 4 years with a person. Like, is this person fun to be around? And Martin definitely is fun to be around. And so during that time, he was very kind, and so we did some work. He pushed me to publish the research on companion stars, but then he also gave me a lot of freedom and said as long as you work on something interesting. And there was a time when I started, like, to know, on TARDIS, which is a rate of transfer code, which is open source. I was part of the AstroPi project. The AstroPi project really taught me to work with not computer scientists, with software engineers, and, like, testing and things. I guess I owe a lot to the AstroPi project. I was one of the founding members, but I learned a lot from them. How do you make an open source software? And then I applied the same thing to TARDIS, and working with Stuart Simondis, who sort of said, like, if you want to write an open one, I can help you and I can guide you on how to do the physics. And so that's how it got done. And Toronto was, in many aspects, a great time. I met a good colleague and friend of mine named Tuan Do, who many years later, with Andrea Ghez, worked on the discovery of the closest approach of the star near the black hole, near the center of the Milky Way. So I was on one Nobel Prize winning paper, and but did a very small part. I did radial velocity measurements, but that was one thing I would have never thought I would work on the Galactic Center. But it was great fun, and I learned a lot. And really, I mean, Andrea Ghez was always very kind and invited me, so I got this connection from Toronto. And then I went back to my hometown of Munich to European Southern Observatory, and then that was very exciting as well. This is where I learned a lot about observatory operations, and also specifically about peer review and all of these like telescope proposals. And there, a mentor of mine, Jason Speramier, like pushed me on literature is growing, and that sort of got me interested in really the literature. And yeah, I think that was one of the nice connections I had there, and also the Max Planck Institute for Astrophysics with Hillebrand and other people was next door, so I had many supernova connections. But I also realized at that time I really was excited about machine learning, so the emulator stuff was something that was. This is a method we developed to really accelerate the code TARDIS by a factor of 100 million. There were several steps to this, but also made a connection with Patrick van der Smark and Newton Chen, who were pure machine learning professors. And it was random connections via some executive of Volkswagen that I met at some conference because I was excited about this. And yeah, then we did neural networks in 2018, which now is a big thing, but back then.
Yeah.
And then I got this wonderful position at Michigan State University, where was the interview I had where one professor asked me over dinner and said, "Oh, what else do you do?" And I told him about this natural language processing work that I'd be doing, or with the literature. And he said, "Oh, this is so exciting! You should think about making this a proper scientific part of your scientific portfolio." And it was the first time where I thought, wow, someone doesn't say "Oh, that's nice that you have a hobby," but they took this seriously. And so Andrew Chrisley, many other people, Brian O'Shea, and other people really made me feel welcome as an interdisciplinary researcher, as someone who has a wide, diverse a set of interests. But I didn't know Michigan State University at all. I just saw oh, there's this position that is dual appointed, and between people that think about math and algorithms and people that think about science. And I was excited about this. So many random coincidences. My life could have gone many different ways, but no, this is how it has gone for now, and I'm excited to see what's next. But advice I can give is follow your passion. Sometimes be a little bit crazy. Don't be too crazy. Make sure you have a paycheck the next month. But other than that, and again, don't be afraid to quit if something doesn't work out. If sometimes you think you have one dream and then you realize actually, no, this other thing was much better in hindsight.
Yeah. That's actually quite interesting. So, in general, we have, let me think, we are trying to do things in our passionate fields, and then we always at least try to plan through the 1 month ahead, but there can be a lot of random things or coincidence, etc., that might actually guide us towards a much better fitting place for us. So we should also keep our eyes open and be a bit open-minded about it, right?
Yes, I think that's very well put.
Yeah, thank you very much again. So we are now at the last question, but not the least part, of course, maybe the most interesting part because it is more current times as well. So I would like to listen to you about your current both computational metascience and astrophysical transients related works. Which one would you like to start first? One?
Let's start with computational metascience.
Okay. So
So I
how
mean, go
what would
ahead,
you like
please.
to sorry. What would you like what are you currently doing it, and how do you feel about it in these fields? Of course, we you have made some introductions too, but I definitely think there are more to it too as well.
Yeah, I mean, I think it's I think it is one of the most exciting fields to be in right now. I think because due to the rise of LLMs, but also due to the rise, and you can see this in UNESCO publishes these report on how much money goes into how many people are employed by research and development. That is rising rapidly. That is the number of people that are in research and development is increasing rapidly. And so we're really at this perfect storm where like the culture, the academic culture we had was not designed for the masses, and this is not meant in a negative way. It was, I think, like few percent or so 100 years ago were going to universities, but the jobs and the opportunities we have in front of us, many more, like probably 50, 60, 70% of the population require a degree in at universities, and then they will go out and they will do more science in academia as well as elsewhere, and then they publish like a lot of results and a lot of papers, and specifically in a digital world where things like, I mean, it's not no longer printed on paper, many people are involved in large experiments, like the expertise does not lie with a single person. It's not Newton and his telescope. It's a multidisciplinary, multifaceted team of, like, many people that make things possible. And I think in industry this is more understood than it is in academia. And so I think, like, thinking in academia, like, how do we measure impact? How do we capture everyone? How do we deal with, we have still this system which has held to this day, and I want to say it's 600 plus years old, of peer review, where we self-govern. No one tells us what the truth is, but this is we discuss this, and other people that are our competitors look at our work and try to take it apart. And I think this is probably why for so long we've held trust in the public, because we just don't trust each other. There's checks and balances. But I mean, as we publishing, as I said, like, in astronomy alone, like, many tens and hundreds of thousands of papers per year, and that is rapidly rising, as we are slowly starting to lack the ability to find experts in this global interconnected world. And I think that's something that the Deep Thought Initiative is looking into. And the first thing is to uniquely identify people, to sort of say, like, well, I mean, Garai, this is Garai, and Garai knows about these different fields, and this is Wolfgang, and Wolfgang knows about these different fields, but there's many Garais and there's many Wolfgangs. How do you uniquely identify the Wolfgang that's from Michigan State rather than the Wolfgang that's from Michigan State, or rather than another person that works at, I don't know, Ohio State University, or in Istanbul, that has different expertise? And so, like, this is, I think, a really nice project we're doing with the grad student center, Amado Olivo, who has another very interesting path, because he was an accountant and came to me as a summer student. Like, don't know, many chances, right? I mean, um, and he was an undergrad in accounting, and sort of started working in computational metascience. And I think, like, that is something that we're pushing for. We now have a new student, Joe Petraka, and we're trying to, first of all, uniquely identify all people, uniquely attribute the publications they've made, and then we have some ways of using expertise. We can have some different methods to do expertise matching. And there again, we just tried LLMs, which are worse. So not always the newest AI is not always better at things, but it's sometimes worse. And we used older techniques that are much more closely, that match experts more closely than humans match experts. So I think LLMs are great for many things, but it doesn't always mean it's the right choice for each task. And so, yeah, I think that's the first thing. And ideally, well, not ideally, we want to make this open source. For me, open source is at the heart of many things. I'm passionate about this. I don't think everyone has to do this, but I think we want to make these tools where you or I could go and you could say, I want to know an expert in computational metascience and astrophysics, and hopefully my name would pop up. And we want to make this open source. We want to make different matching algorithms. We just want to make this a little bit more transparent and make it easy to find experts, make it easy for publishers to get referees. Want to make this open source so these community-owned journals can use such a tool. Like, it should be relatively cheap for them to make sure, like, that strengthens the community-owned journals. I mean, obviously other publishers can use it as well. And I think that's something that I'm excited about. The other thing that I'm excited about is we have CMSE department, which is interdisciplinary. The question is, do we train interdisciplinary better than other people? And I think, like, that's another new project that we're trying to figure out. But I think that's it on computational metascience. I don't know if you have other questions on this. Otherwise, I would swing over to astrophysics.
Yeah, we can actually go for the astrophysical transience part because of the time constraints as well for yours.
Yeah.
Other than that, though, it was very interesting. Especially, I would like to definitely try it out when it's since it will be open source and transparency, especially. So, thank you very much for
Yeah.
being making this open source at the end of it.
Of course, of course. There is, I think, I mean, I can give you some preview version and you can try it out already. But it only is for a small field of physics. We want to make this larger. But yeah, it would be fun for you to try it out.
Yeah,
On
definitely.
the astrophysical transients, I think there's many topics. I think like one of my excitements that I have is like really thinking about like how do we make very detailed simulations. We now see this in obviously in the gaming industry and in the movie industry, that we can really simulate physics. Like we can make things in a computer that behave very physically correct. Obviously these things in the gaming industry and movie industry are more designed to look correctly, but we've also like had, we can really in multi-dimensional, like in 3 dimensions over many uh over large timescales, we can simulate how a star explodes or how a star collapses. I mean, my colleague Sean Couch is doing this. And so we have a lot of this very computation expensive but very detailed physics, and then we have an explosion of observational stuff. And we're really in my group thinking about like how do we connect those two? How do we make a simulation that looks exactly like an observations, and then in the computer probe, like, I don't know, we can look at it from different sides, which we in an observation we obviously can't do. So reconstructing and understanding transients, I think, is sort of like one of the things that we want to do. And then, as I said before, is like we have these classes of supernova where we have dead corpses of stars, and corpses of stars, like corpses of humans, normally stay still forevermore, and so they explode in the universe. And so the question is really why we have like the most massive stars in the universe that, like, um, don't seem to show traces of the most common element in the universe called hydrogen. So hydrogen should be there, but I mean the most massive stars, when they explode, seemingly have lost their hydrogen or somehow hiding their hydrogen. And that's a really nice work by one of our postdocs, Jing Lu, and really trying to figure out, like, what happened there. And then the last part I think that I'm very excited about is there was the gravitational wave event GW170817, which was associated with emerging neutron stars, and really that likely this is the source of like all the heavy elements like uranium and gold and other elements in the universe, and really figuring out how often does this happen, how much gold is in the universe, which is obviously a fun question
Yes.
on many levels.
Yes, thank you very much. It was every one of those what you're saying things are quite interesting actually. I believe audience will check your curriculum vitae and the laboratory group's webpage as well to know more about you. So it was definitely for me to. I will closely watch the next publications coming from you and your groups about it.
Thank you. Thank you.
So as a final thing before closing the interview, do you have any final remarks on to your audience? Mostly graduate students,
No,
if not, but you can think of it like
I
everyone from starting from early career and beyond in the astrophysics field.
yeah, I think one of the things that I learned recently is I think there's a thought out there, which it's very wrong, is that research is what happens in universities and academia, and that is no longer true. I have friends of mine that work on oceanography in industries, or like, figure out satellites for remote sensing, and like I think there's lots of, if you're interested in research, there's many places to do this. And so like sometimes like we get 250 applications for astronomy PhDs, and then like if you go to environmental sciences you get much less. Like, don't, like, follow your dreams, but realize there's many ways to live your dream. I think that's a good summarizing statement.
Yeah, thank you very much for your interview. I'm I'm thank. So let me actually more properly so string together the words again. Thank you very much for accepting this interview and sharing important things about your career.